Hello everyone. In this video, we are going to discuss about angles, degree measure and radian measure from the chapter 3 trigonometric functions of class 11 max. You see, what is an angle? Angle is a measure of rotation of a given ray about its initial point. You see, the original ray that is actually called as the initial side and the final position of the ray after rotation that is called as terminal side of the angle. That is, here you see here we have the ray OA. It has been rotated through some angle, so after the rotation it has reached here. So this is the initial side and this is the terminal side. Okay, now you see the point of rotation that is actually called as the vertex. Okay, now if the direction of rotation, if it is in the anti-clockwise direction, okay, if it is in the anti-clockwise direction, then the angle is said to be a positive angle. But if the rotation is in the clockwise direction, if it is in the clockwise direction, then it is said to be, that angle is said to be a negative angle. So if the direction of rotation is in the anti-clockwise direction, the angle is said to be a positive angle. If the direction of rotation is clockwise, the angle is said to be negative. See, the measure of an angle, that is the amount of rotation performed to get the terminal side from the initial side. So, the measure of an angle, that is the amount of rotation performed to get the terminal side from the initial side. You see, there are several units for measuring angles, namely degree, radian, then 1 complete revolution or revolutions per second. See, 1 complete revolution from the position of initial side, that is actually shown in this figure. You see, OA is the initial ray, so this is the initial side. Then this ray, original ray, this initial side, it has been rotated, 1 complete revolution is completed here. That is, it has been rotated through 1 complete revolution. So after that, it will be reaching at the same place. So we are getting the terminal side and initial side at the same place. Okay, so 1 complete revolution from the position of initial side, that is actually shown in this figure. The unit of 1 complete revolution, that is often convenient for large angles. That is, this will be the angle corresponding to this. Okay, that is 1 complete revolution. See, if we consider the angle made by a spinning wheel or wheels of vehicles, etc., we can use the unit and say the angles as 15 revolutions per second, 20 revolutions per second, etc. Now, let us talk about degree measure. See, it is a unit of measurement of an angle. That is, if the rotation from the initial side to terminal side is 1/360th of a revolution, the angle is said to have a measure of 1 degree, which is written as like this, 1 degree. Okay, see, this actually represents 1 complete revolution, 1 full revolution from the initial side to the terminal side, so that the initial side and terminal side will be along the same line. So this actually represents 1 full revolution. Then 1/360th of this 1 full revolution, that is actually considered as 1 degree. See, a degree is divided into 60 minutes. This is how we represent minutes. So 1 degree is divided into 60 minutes. That is, we can write 60 minute is equal to 1 degree. So 1 minute will be equal to 1/60 degree. Okay, that is 1/60th of a degree. That is actually called as a minute. Okay, 1/60th of a degree is actually called as a minute. And you see, 1 minute, it is divided into 60 seconds. Okay, this is how we represent seconds. 1 minute is divided into 60 seconds. That is, 60 seconds is equal to 1 minute. So 1 second is equal to 1/60 minute. Okay, that is 1/60th of a minute is actually called as a second. Now, let us see how to represent the 360 degree angle. 360 degree angle corresponds to 1 full revolution of the original ray. So here you see OA, that is the initial side of the angle, that is, this is the original ray. Now one full revolution of this ray means from here the terminal side also will be along the same line. So both the initial side and terminal side, they will be along the same line, and the angle corresponding to that is 360 degree. So this is 360. This angle actually represents 360 degree. Okay, now how to represent 180 degree? Simply 180 means positive angle plus 180. So 180 degree will be half of 360. So from here to here, that is 180 degree. That is the terminal side, this OA is the initial side. So terminal side OB will be along this direction. Okay, now let us see how to represent 270 degree angle. You see, this is the original side or initial side OA. Now terminal side, where should be the terminal side? 270 degree angle, no? So 90 plus 90, 180, 180 plus 90, 270. Okay, so we will get the terminal side here, OB. Alright, and the angle corresponding to this is actually equal to 270 degree. Now let us see how to represent 420 degree angle. See, one complete revolution, 360 degree angle plus 60. So plus 60 means somewhere here. So this will be the terminal side OB. So angle corresponding to this, that will be equal to 420 degree. Now if you consider minus 30 degree, so minus negative angle, so the angle should be measured in the clockwise direction. So this is the initial side, then clockwise rotation. Okay, then suppose the terminal side is here after 30 degree rotation. So the angle corresponding to this is minus 30 degree. Similarly, if you consider minus 420 degree angle. Minus means clockwise rotation. So this is the initial side OA. So one complete revolution, 360. Then 60 more. So 60 more will be somewhere here. So you see, this side will be the terminal side, and this angle corresponding to that is minus 420 degree. Okay, see, if angle is measured or if the rotation is in the clockwise direction, then angle is negative angle. If the rotation or if the angle is measured in the anti-clockwise direction, that is actually the positive angle. Now, let us just talk about the radian measure. You see, this is also a unit of measurement of an angle. So, consider a unit circle, that is a circle of radius 1 unit. Now, consider an arc of length 1 unit. Okay, that is we are considering a unit circle, that is a circle of radius 1 unit, and we are considering an arc of length 1 unit in the unit circle. Then the angle subtended by this arc of length 1 unit at the center of this unit circle, that is this angle, that is said to have a measure of 1 radian. Okay, so you see, this figure shows the angle whose measure is 1 radian. See, OA is the initial side, OB is the terminal side. Here it is a unit circle, that is an angle of, a circle of radius 1 unit. We considered an arc length of 1 unit. Then the angle subtended by this arc at the center of this unit circle, that is actually equal to 1 radian. Okay, similarly, minus 1 radian will be what? It will be measured in the clockwise direction. So unit circle of radius 1 unit, arc of length 1 unit, and if the angle is measured, that is if the initial side is rotated through, in the clockwise direction, we will get the corresponding angle as minus 1 radian. Similarly, you see, this is how we represent the 1.5 radian, because we are considering a unit circle of radius 1 unit, then we are considering an arc length of 1.5 unit, then the angle subtended by this arc will be 1.5 radian. Similarly, minus 1.5 radian will be represented like this, that is we are considering a unit circle of radius 1 unit, then we are considering an arc length, this is the arc of length 1.5 unit, then you see this arc subtends an angle at the center of this unit circle, that angle is minus 1.5 radian because we have rotated this initial side in the clockwise direction. Since the arc length is 1.5 unit, its angle will be 1.5 radian. Since the initial side is rotated in the clockwise direction, it is minus. Okay. So you see what is 1 radian? The angle subtended by the arc of length 1 unit at the center of a unit circle that is said to have a measure of 1 radian. Now consider a unit circle. Unit circle means its radius will be 1 unit. If we consider one complete revolution of the initial side, OA is the initial side. If we consider one complete revolution of the initial side, so OA will start rotating from here, then after one complete revolution, it will reach here. So the final side also will be along this OA. So the corresponding angle will be what? 2 pi radian. That is here. If we consider a circle of radius 1 unit and if we consider one complete revolution of the initial side OA, the arc length will be equal to what? The arc length will be the circumference of the circle. See, the circumference of a circle of radius 1 unit is 2 pi. So here the angle subtended will be equal to 2 pi radian. Okay, that is one complete revolution of the initial side subtends an angle of 2 pi radian. That is in general, if you consider a circle of radius small letter r, an arc of length small letter r will subtend an angle of 1 radian. So in a circle of radius 1 meter, an arc of length 1 meter will subtend an angle of 1 radian. Now you see, equal arcs of a circle will subtend equal angle at the center. That is, here you see, here we are considering an arc of length L. This subtends an angle at the center, that angle is theta. Okay, now if you consider another arc of the same length L, that arc also will subtend an angle at the center, that also will be equal to theta. Okay, similarly here you see, if you consider an arc of length 1 unit, it will subtend an angle at the center, that angle is theta. Then if you consider another arc of length 1 unit in the same circle, that will also subtend the same angle theta at the center. So equal arcs of a circle will subtend equal angle at the center. Now you see, in a circle of radius r, suppose we are considering a circle of radius r, an arc of length r, that is if you consider an arc, that arc, we are considering an arc, its arc length is small letter r. That is, in a circle of radius r, an arc of length small letter r subtends an angle that its measure will be equal to 1 radian. Okay, that is, in a circle of radius r, an arc of length r subtends an angle whose measure is 1 radian. That is, r length will subtends an angle 1 radian. Okay, so a unit length means 1 length. A unit length means its magnitude is 1. It will subtend an angle of 1 by r radian. So L length will subtend, that is an arc of length L will subtend an angle L by r radian. Okay, so if you consider an arc of length L, that will subtend an angle. Okay, here you see we are considering a circle of radius r and we are considering an arc of length L. See, this arc of length L will subtend an angle whose measure is L by r radian. So here if you consider this angle, consider this circle of radius r. Here we have an arc of length small letter L that subtends an angle theta here, theta radian at the center. So here we can write this theta will be equal to L divided by r. So this is actually like angle is equal to arc length by radius. Okay, from this you can write L is equal to R into theta. Alright. So in this video we have discussed about the angles from the chapter 3 trigonometry functions of class 11 max. We have discussed about the degree measure and radian measure. I hope it is clear to you. Thank you.